Hello students, welcome back to the second part of the lecture of CNC part programming. Myself, Dr. Borat M. Burgosari, Assistant Professor in the Department of Mechanical Engineering, Jorhat Institute of Science and Technology. So in this part, we will be discussing the CNC part programming with some examples. Okay, so let us discuss the part programming, the word address coding. So here we can see the simple sample program. So its instruction to the machine consists of letter followed by a number. So each letter is consisted with a specific type of action or piece of information needed by the machine. The letters used for the code are N, G, X, Y, Z, A, B, C, I, J, K, then F, S, T, R, M. Okay, so N is the for sequence number, Z for preparatory code or function like a Z00, Z01, then X, Y, Z, A, B, C, I, J, K are used for coordinate system. Then you have the fit for F, then S for speed, then T for tool, then R for radius, then M for miscellaneous function like M05, M06 for coolant on off or spindle on off. Okay, so let us discuss this simple program one by one or line by line. So in the first line, N05 is the sequence number. So you have to start the sequence number by intermediate number like N0, N05, N10, N15. So what is the advantage of this intermittent sequence number is that suppose if you want to edit the program, then if you want to insert some line on the in between the N10 and N15, then if you write the continuous sequence number like N10, N11, N12, then in between N10 and N11, if you're supposed to insert the sequence number, then you have to change the whole sequence number for other line of code also. So the advantage of using the intermediate sequence number is that in between N10 and N15 you can insert four number of new line of codes. Okay, so that is the advantage. Basically it is the user choice whether they want to give the intermediate number or continuous sequence number. So first one is the N05, this is the first sequence number. Then next one is the Z90, that indicates the, if you have remembered the code, then that will represent the absolute dimension system. Then Z20 will be represents the inch unit system, that is all the dimensions will be measured in the inch. Then next line is the N10, that is the next sequence. So M06 is the command for tool sense. So it will call the T3 tool number, and it will be bring to the mandrel of the tool holder. Okay, so the tool has been sensed by using the M06. So the tool number whatever you have taken is the T3. So the T3 tool specification will be available on the machine itself. So no need to worry about the T3, the tool dimensions. All the dimensions will be available on the machine itself. So you have called the T3 number tool. Then in the next sequence you have given the M03, that is the rotation of the spindle in a clockwise direction. Okay, so you have instructed the this spindle to rotate in a clockwise direction with a speed of your 1250 inch per minute. Okay, so that will be your unit system you have taken. So S represents the spindle speed, that will be the 1250 inch per minute. Okay, so next line will be the instruct the N20, that is Z00. So Z00 will be used for repeat traverse. So either you can move the table or you can move the tool along the XY direction. So you can move the tool in a repeat traverse to X1 and Y1. So basically in case of drilling machine, the drill bit will be fixed, so you have to move the table. So that Z00 will instruct the table to move in the 1 inch in the X direction, 1 inch in the Y direction. So the table will traverse with the maximum speed available on the servo motor on the table. Then in the next line N25 or sequence, that will be the 0.1. So Z.1 means the tool or the drill bit will be approaching the workpiece up to the 0.1 inch. So surface of the workpiece will be considered as the zero position for the tool, means that is the Z0. So the tool will be moved to 0.01 above the work surface. Then N30, that is the Z01, that is the linear interpolation. So it will move with the specified speed, and Z is specified as the minus 0.125 inch. Okay, so what it means that the drill bit will be moving in a downward direction, that is it will be drilling the workpiece up to a depth of 0.125 inch with the feed rate of 5 inch per minute. Okay, so next one is the N35, next sequence, then X3, Y2 and F10. So that means the X table will be moving in the X direction up to 3 inch, then Y direction 2 inch, and feed rate will be the 10 inch per minute. So what it means, the drill bit is rotating in a clockwise direction with a speed of 1250 inch per minute, and along with the spindle rotation you have moved the tool to a different location. Okay, so the depth of drilling is same, minus 0.125 inch. So along with that depth of drill, you have moved the tool to a new position, that is X3, Y2, and with the feed rate of F10. Okay, so unless tool compensation is used, the coordinates are associated with the center line of the tool. So if you take the example of 10 mm and 20 mm drill bit, if you don't use the tool compensation, then the coordinates will be same for both the tool. But if you use the tool compensation, there will be a 10 mm difference between the two tools. You have to specify the coordinate for the tools. Now, as an example for the motion of the motion that occurs in XY plane with the same maximum speed for X and Y axis, initial motion is at an angle of 45 degree to the axis until motion in one of the axis is completed, and then the balance of the motion occurs in the other axis. This is called a point-to-point motion. So this can be explained in the next figure. So what it means that this is the XY plane where you are moving the drill bit from the position A to C. So you have given the instruction to move the tool or table from A to C. So let us assume that the servo motor for X and Y coordinate have the same maximum speed. So since the distance A to C have more length in X direction compared to the Y direction, so what will happen here is that both the servo motor have same maximum spindle speed. So in the first movement, both the spindle will rotate in a maximum speed, and it will cover the path, making an 45-degree angle because both the motor have same spindle speed. After reaching the B position, since you have reached the Y coordinate and still the X coordinate is yet to be reached, what will happen? The next movement will be along the X direction only. Okay, so next we'll be discussing the G02 circular interpolation. So G02 is also a preparatory function to specify that the tool should be moved to a specific location along a circular path in a clockwise direction or in anti-clockwise direction. So G02 will be used for clockwise direction and G03 will be used for counterclockwise or anti-clockwise direction. So in order to specify the path to a machine control unit, the endpoints of the arc and the location of the center of the arc should be specified. So that you have to specify in case of circular interpolation. But in case of linear interpolation, that you have to specify only the final position of the tool. So within the block in which the G02 code is programmed, the center of the arc is given by specifying its location relative to the start of the arc. So G02 command is requires an endpoint and end radius in order to cut the arc. So in this case, we'll be using the IJK for the start point. So here you can use the two line of codes. Either you can specify the endpoint and final coordinates of the workpiece, or you can directly specify the radius of the arc. So in the first case, the n will be the sequence number, then this is Z02 will be required for circular interpolation in a clockwise direction, then and that x2 and y1 is the final position of the this arc. So in this previous line of this code, that will be the initial position of the x and y. So that initial position will be the x1 and y2. Okay, so it should be in the previous line. Then in the this circular interpolation, you have to specify the final position, that is the x2. X is 2 here and y is 1, and what is the position of your center line? So that is the your I is 0 in x direction, that is 0, then y is reduced from 1 to -1, means -1 you have reduced. So x position is 0 here. In x direction you have not moved any distance, whereas in y direction you have moved -1 direction. Okay, so here to specify the this center position, you have to take the initial position as the origin. Okay, so this is the method. And when you're using the radius, then you don't need to specify, just you have to use this sequence number, then this is Z02 for circular interpolation globalization, then final position in x and y the coordinate x2 and y1, and you have to specify the radius, with which radius you have to go for the circular interpolation. So the second one is easier compared to the first one, because you have to find out the relative movement of the center from the initial position. So here also again you can find out the similar method. So this is circular interpolation. So from A to B you have to move the circular interpolation. So this is the n10 is the sequence number, you have to use the Z02. So this is the final position, x20. So this number is multiplication some is used. So you can take the 20 x20 here, then y is 10, then you have to find out the relative movement from this initial position. So the center is here located in the C. So this C position is 5, you have moved along the x direction, and 15 along y direction, I5 and J15, and F is represented 25 unit per minute. So next one is the can cycle. If you want to write a code to perform a similar kind of operations, then you can use the can cycle. So these can cycles are useful when you're performing the drilling or boring operation. So the sequence of some machining operations is maybe the same for any part or for any machine. For example, drilling a hole involves the following steps. So you can take the example of drilling. So like if you take a rectangular block and you have to perform the 4 holes on the corners of the workpiece, then the process will be same for all the 4 holes. So the steps will be the position where the hole will be drilled, then set the correct spindle speed, then feed the tool into the workpiece at the controlled feed rate to a predetermined depth, then rotate the tool at a repeat rate to just above the point where the hole started. Okay, so this is the process. So after finishing the process for one hole, you have to move the tool to next position and repeat the process from this first to the last. So to perform this operation, you can use the can cycle, and this can cycle will operate perform all the drilling operations for you without writing the long code. So these are the codes already described to you. So G81 is used for drilling, then G82 is used for spot phase counter boring operation, So then G83 is the deep hole drilling, then G84 tapping operation. If you want internal thread, this process also same. Then if you want to perform the throw boring operation, then G86 throw boring in only continuous feed stop spindle and rapid reverse retraction is used. And G80 is for cancelling the can cycle. So this is a simple example when you're drilling 3 holes with or without can cycle. So first code CNC program will represent the drilling the 3 holes without the can cycle, and below CNC code is represents the drilling the 3 holes with the can cycle. So let us see how we can be using the can cycle. So if you don't use the can cycle, you have to write the code for all the 3 holes. So N10 is the starting sequence number, Z00 rapid reverse, then it will traverse to the X25, Y35, Z2. So this is the initial position A, where it is the all the coordinates will be 00, and the surface of the workpiece will be taken as the 0 position for Z direction. Okay, so you have to move the tool from this A to B first. So the coordinates are 25 and 35. So the tool is positioned here in the B position. Okay, then you have given the Z01, that is the linear interpolation along the Z direction. You have moved the tool to drill a depth of minus 18 millimeter. If the dimensions are in millimeter, then the feed rate will be your 125. So before performing this drilling operation, you have to give the spindle speed also. So you have to use the M03 for spindle rotation, the clockwise direction, and spindle speed, that is 1250. Then in the next line you can go for the linear interpolation, and that is your Z in the minus 18, that is the 18 millimeter depth you have to drill with the feed rate of 125. Then you have to retract the tool to a higher depth, that is Z2. Then again you have to reposition the workpiece to a newer position. So that should be your X55, and it should be Y50, and you have to go rapid reverse to the next position. So you're using the absolute positioning, so that absolute positioning and unit system should be specified before this first line. So we are not discussing about that, we are discussing only the can cycle. So here what you can do, N25 is the sequence number, so the tool is here at right moment. Then you have to move the tool to this C position, so you have to traverse, this is the 55. Okay, so 55, and around that it is 50. So you have traversed this one, so you don't need to specify here again, I have already specified. So you have moved the tool to that position, and you have to specify the Z minus 0.0. Okay, so N35 G01, then Z minus 18 F125. Next one is the N40 Z00 Z2. You have again retract the tool to in this position C. Then you have N45, sorry that line is mistake. Then you have to use the Z00. What is the position of D? The position is should be 75. Okay, then X is 75 and Y it is 70. It is 70. Okay, so you have moved the tool from this C to D. Then you have to perform the Z01, so this line is not required now. Instead of that, you have to write Z minus 18.0 and the feed rate with the feed rate of 125. Then again you have to retract Z00 Z2. Then in that you have to move the X0 Y0 Z. 50, it is the highest depth you have taken. So you can set the home position, and then you can in the end 070 you can write M30. So before that you have to write M05 and then N075, you can write M30. Okay, so this is the code when you're not using the CAN cycle. For when you're using the CAN cycle, what you can do, N10 Z81 is the CAN cycle for drilling, then X25 is the initial position of B coordinate, X25 and Y35. Then you have to perform the minus 18 millimeter depth drilling. Then this is the R2 that is not required here, that is of the tool. So F is that feed rate. So Z81 you have specified that is a CAN cycle, so it will operate this operation Z-18 and F125. So CAN cycle will repeat this process Z-18 and F125. So you have to only show the next position. So in this Z81, what is hidden here is that first it will drill 18 millimeter depth and it with the feed rate of 125, and it will retract the tool initial position. So before that, what you can write is that you can write N005 Z.0, and before this line you have to specify the ASRO system and the unit system. That this is common for all the codes. So we are discussing now only the CAN cycles. So this N005 is that Z2.0 is the initial position. So this Z81 cycle what it will do is that it will perform the drilling operation up to the depth of 18 millimeter with the feed rate 125, and then it will retract the tool to a Z2.0 with a rapid reverse. Then these operations will be repeated by using the CAN cycle Z81. So what your work is to do that is that you have to show the next position. So in the next line you have to only show the next position, that is X55 and Y50. So when there is a change in the position, after changing the position, this Z81 will perform the this process, means drilling operation, and after completion of drilling operation, next it will search for the next position. So next position will be the X75 and Y70. Okay, after this new position is specified, then it will perform the drilling operation based on this Z81 cycle, and when it will finish the operation, it will retract back and it will search for the next position. So when you specify the Z80, then it will understand that CAN cycle should be cancelled and the position tool should be moved to a new position X0, Y0 and Z50. Okay, so this much line of code has been reduced by using the CAN cycle. Okay, so this is the advantage of using the CAN cycle. So this is another illustration of Z81, that is the CAN cycle. So this is explained here when you don't use the CAN cycle. In the next video we'll be discussing of the some milling operations.